Alright, next, in 7.2, we have bearings. Bearings is used to provide information about directions. Alright, in taking bearings, there's always a point of reference. Okay, and it is measured from the north in clockwise direction. Okay, so clockwise from the north. And the last thing, bearings are always measured in degrees and expressed in 3 digits. Okay, so these 3 important information we need to know when we have questions on bearing. Okay, so bearings are always denoted by 3 digits. So in the case of a calculation, maybe we have answer as 18. Alright, we add a 0 to the front to make it 3 digit. Okay, so 0 and 8 degrees. Alright, so if you have decimal, for example 23.8 as your answer, you add a 0 in front of 23, so 0, 2, 3. Okay, to make it 3 digits in front of the decimal place. Okay, so we can look at example 4. Okay, bearing of. In a bearing question regarding bearings, you will always be given the north arrow to indicate where is north with respect to the diagram. Alright, so in this case, okay, we can say that A is directly north of B. Okay, A is directly north of B. And C is directly east of B. Right? Or B is due east of C. Okay, due west of C. Okay, we can say that B is due west of C. Alright, because if we are standing at point C, B is to the west of us. Okay, so you can recall the direction: north, east, south, west. Okay, and vice versa, C is due east of B. Okay, the word due east, due west, due whichever direction, right, means that it is directly to the direction which the question is stating. Okay, so now let's look at the questions here. Calculate bearing of B from A. Alright, so now A is our reference point. Okay, reference point, which is mentioned above just now. So how to calculate? We can place our north arrow at our reference point. Okay, and then we rotate clockwise. So to part A, the answer is 180 degrees. Alright, because we rotate until we stop at the line which is formed between point B and the reference point A, we get a straight line. Alright, this is north-south, is a straight line. So we will get 180 degrees. Next, bearings of C from A. So in order to find bearing of C from A is still our reference point for this part B. Okay, but we do a clockwise rotation. We stop at this line C. Okay, AC. So this is the angle that we are supposed to find. So we can use 180 subtract by 35. Okay, what we will get is 145 degrees. Okay, so next, okay, in part C, we realize that our reference point have changed. Okay, part C of this question, they have changed it to bearings of A from B. Okay, so now we got to put our north arrow at B and take the bearing of A from B. Okay, we realize in this case, okay, it is exactly to the north. Alright, so if we can't rotate clockwise or anti-clockwise. If you rotate, it will form a full circle. If you do not rotate, it is already sitting on the line that connects with point A. So for this question, we can give our answer either as 0, 0, 0 degrees, alright, or 360 degrees. Okay, so this is bearing of A from B. Okay, and next, we are supposed to find the bearing of C from B. Okay, B is still our reference point. We can put the north arrow at our reference point. Okay, we realize it will form a right angle, which is given in the question. So this is 090 degrees. Okay, C is exactly due east of B, so it's to the east of B, so it's 90 degrees. Part E, alright, if you look at the difference between question B and E, okay, we look at where is the reference point. Okay, bearings of C from A and bearings from A from C. Realize the reference point change, okay, between these two questions beside each other, part B and part E. So in part B, we put our reference point at A. Okay, in part E, we are supposed to shift our reference point to point C. Okay, and then we measure the angle. Okay, we rotate clockwise until this line which connects C from A. So this is the big angle that we're supposed to find as bearing. Okay, which is different from the answer in part B. Although the points involved are the same, the reference point change, so the angle, the bearing angle will change. Okay, in this case, we are supposed to find. So how do we find this? Okay, we have already worked out this in earlier part. This angle here is 145 degrees. Okay, and one thing to note, okay, all norths are parallel to each other. Okay, all north lines are parallel to each other. Alright, unless you're standing on the North Pole itself. Okay, so for all the questions that you will see, you can take that all the north are parallel to each other. So in this case, we have two parallel lines. Okay, and the angles between them, these two, we call it alternate angles, and they are equal. Okay, alternate angles, a bit of a revision, alternate angles. So we can find this bearing by using 180. Okay, this is 180 degrees plus 145 degrees. Okay, so this is 145. So we will get 325 degrees. Okay, we can put in the reasons, alternate angles, because we use alternate angles to identify this big angle is 145. Okay, next, bearing of B from C. Okay, bearing of B from C is pretty straightforward because B is directly due west of C. So, okay, we know that this is right angle, this is 180, and this is another right angle. So it will be 270 degrees. Alright. Okay, in example 5, no diagram is given. Alright, so we are supposed to find the bearing of B from A. Okay, information given, bearing of A from B, reference point is B, is 50 meters. So what we can do, okay, we can mark out do a rough sketch ourselves. So A from B, so the north is at B. Okay, we have a 50 degrees. So A should be slightly in this position. And if we were to find the bearing of B from A, we put north at A. Okay, we rotate. Alright, so we have the same thing here. This angle, which I color out, this is 50 degrees because alternate angle on north are parallel. Okay, so bearing of B from A will be equals to 180 plus 50 degrees. Okay, so we get 230 degrees by using the property of alternate angles. Okay, in example 6, state the bearing of B from O. Okay, so as we answer, of B from O. Okay, O is here, so we use 90 degrees plus 35, which is already given, so we will get 125 degrees. Okay, and next part B, bearing of D from O. O is still our reference point, so the point D we can use 270 degrees plus 46. Okay, so 270 degrees plus 46 degrees, we'll get 316 degrees. Okay, so this is our answer for B. Next, in part C, bearing of O from A. So the reference point have shifted to point A. So we have to put our north at A. Okay, so north is at A. So we rotate. We're supposed to find this angle. So using alternate angles, we can tell we have 50. Okay, these two angles, this is also 50. Alright, so in part C, okay, bearing of O from A, we can use 180 degrees plus 50 degrees, okay, to get 230 degrees. Okay, next part, part D, bearing of O from C. So we put our north now at C. Okay, angle that we must calculate is this angle, clockwise. Okay, so question D, bearing of O from C. Okay, so we can tell that it is 0 to 0 degrees, 20 degrees. Okay, because of alternate angles. Okay, we have north and this north line, so it forms alternate angle. Okay, the last one, bearings of O from D. Okay, so we put our north at D, right, and we rotate clockwise. Okay, we're supposed to find this angle here. So how can we find this angle? Okay, one way is to make use of this angle here. Alright, or we can use alternate angles. Okay, alternate angles. So this is also called the north line. So we have alternate angles. Okay, so this angle is 90 plus 46. Okay, so 90 degrees plus 46 degrees. And we will get 136 degrees alternate angles. Okay, so these two angles are alternate angles. So if we can find the angle here, we will be able to get the angle here. Alright, so this is example 6.